Hello, Applied Calc. I'm going to go ahead and do 2 or 3 examples of absolute maxes and mins. So here we have absolute max and mins, and I'm just going to give you a quick reminder that our absolute maxes and mins, okay. All right, so here we have 4 points. Now this one is a relative min. This one is a relative max. This one is the absolute min because it is the lowest point. But similarly, this point here is the absolute max. And so when we are looking to find our absolute mins and maxes, okay, we first need to find the critical numbers, right? Remember, this is where f prime equals 0. And so I'm just going to highlight those portions on the graph, okay? The f prime equals 0 is what will help us figure out if we have any relative mins or maxes, okay? The second thing we're going to do is the f prime number line. That way we can determine if we have a max or a min possibility, okay? Now,
What was the time on this point again?
the third thing that we're going to do is test the points, okay? And when I say test the points, I mean that we are going to compare the endpoints, okay? So that right there would be, okay, the endpoints, which would be this one and this one, okay? We're going to compare the endpoints to the critical numbers. And we're going to do that by making a table of values. All right, so the maxes and mins are typically, they're actually the y value, which is why we need to test the points. And when we test the points, endpoint, critical number, endpoint, we are comparing the y values here. Okay, so it's good, right? Notice that right here, instead of doing calculus-based conclusions, that we're just comparing the points. So step 3 is the only step that is different. Okay. Find absolute max and mins. I'm going to give you f of x equals 2x squared minus 8x plus 1.
Miss Eden, I
and
get a tiger.
x interval is going to be from -1 to 3. All right, so let's follow our steps. First thing we're going to do is find our critical numbers. Okay, critical numbers. Here we go. Okay, x equals 2. Now, I am also going to graph this in Desmos. Okay, and this is at x equals 2. All right. Number 2, make my number line. Okay, f of x, f prime, and x. Okay, x is the only value here. All right, and I need to, okay, negative, positive, okay? And now I need to very quickly, all right, decreasing, 0, increasing. Okay, so what I am going to do next is figure out what to label these points. Now I can see that this is the only low point. So the third thing we're going to do
Mommy, we didn't have time again.
is compare. Okay, so my endpoints are, I like to label my endpoints. Okay, so -1, my critical number is 2, and then I get a 3. All right, so I'm going to go ahead and plug in. Now, when I say test the y values, I mean from the original function. So if I plug in -1, 2, 11. Okay, now I'm going to plug in 2. So this is an 11. Okay, 4, 8. So this one is -7. So this is -7. I'm going to plug in 3. And that is -5. Okay. All right, let's label this up. What do we have? This one right here is the absolute and relative min because it is the lowest value. This one, okay, that's the relative. See how it's a turning point? That's a relative, but it's the lowest number, which makes it the absolute. Now, okay, the highest number. Notice how this is an endpoint, so this is only the absolute max. All right, absolute max. This is the absolute and relative min. The right endpoint is nothing.